Welcome to the deep dive. Today we're plunging into, well, a really fascinating area, making large language models, LLMs, work better when they need very specific, maybe even private information.
That's right, because as you know, when you're trying to use these really powerful models for specialized stuff, maybe internal company docs, complex medical research, legal things, the general internet knowledge, it's often just not enough.
Yeah, you'd absolutely need to connect them to your own domain-specific data somehow.
Exactly.
And traditionally, the tech world has tackled this in like two main ways, right?
Yeah.
You've got Retrieval-Augmented Generation, RA. Everyone's talking about RAG.
Everywhere, yeah.
And then there's fine-tuning. You hear those terms constantly.
Constantly. So think of RA as giving the model a way to look stuff up while it's answering your question during inference, basically.
Okay.
You have a database, your documents, and when you ask something, a retriever system pulls out what it thinks are relevant bits of text and, adds them to the prompt the LLM sees.
Right. So it's kind of like an open book test. You haven't really memorized it all, but you've got the book right there.
Exactly.
But your success totally depends on whether you or, well, the retriever can actually find the right page, the right sentence in that moment.
That's a good way to put it, a helpful analogy. Now, fine-tuning is different. That's more about getting the knowledge in before the test, during the training phase.
Okay.
You take a base LLM and you keep training it, but on a big data set that has your specific information, you're trying to embed that knowledge directly into the model's parameters.
Right. So that feels more like studying like crazy for a closed book exam.
Yeah.
You've crammed all that specialized knowledge in beforehand, but then on test day, you just got to rely on what it memorized.
Exactly. And the limitation there is pretty obvious, right? It only knows what it was trained on. If new information comes out after training.
It's stuck. It can't access it.
Stuck. Precisely. So, look, both techniques are valuable, but they definitely have their limitations, especially when you need top accuracy, reliability, and, dealing with data that changes.
Yeah, RAG really leans on having a perfect retrieval.
It is hard. Super hard. And the model might still struggle to make sense of messy results.
And fine-tuning is good for static stuff, but it can't adapt and might get confused by questions just outside its training.
Exactly. Which brings us to why we're doing this deep dive today. We're looking at a technique trying to bridge that gap, kind of combine the best parts of both. It's called Retrieval-Augmented Fine-Tuning, or RAFT.
RAFT.
RAFT. It's this unique approach, came out of research at UC Berkeley, and the core idea isn't just slapping retrieval onto a fine-tuned model.
Right.
It's about fine-tuning the model itself specifically so it gets better at using retrieved documents. It's a tighter integration.
Ah, okay. So it's not RAG and then fine-tuning or vice versa. It's a training method that changes how the model fundamentally learns to deal with external info.
Yes. You're building the skill of doing RAG well directly into the model during its training.
It's teaching it how to use the documents effectively, not just hoping it figures it out when you dump them in the prompt.
Exactly that. Teaching the skill.
Okay, let's go back to the exam analogy again. Fine-tuning. Closed book. Studied hard. Argy. Open book. Didn't really study. What's RAFT?
RAFT is like. It's the open book exam, but you did study for it. And crucially, part of your studying was practicing how to use the book efficiently during the test.
Okay, that makes sense.
You've got some foundational knowledge baked in, but you've also trained specifically on finding, understanding, and pulling together info from the reference material quickly and accurately.
That feels way more robust.
Yeah.
You've got the baseline understanding and the practice skill of using the resources.
Right.
And I like that other analogy they used, the fishing one. Give a model a fish.
Yeah. Feed it for a day.
Teach it to fish, feed it for a lifetime.
Traditional RAG feels a bit like just handing the model some potential fish these documents and saying, good luck.
RAFT is actually teaching the model how to fish, how to sort through the documents, find the keepers, ignore the junk, and actually land the right answer.
Teaching it to fish using external data. Yeah, I think that sums up the philosophy pretty well.
Okay, so it's a fine-tuning technique. How does the teaching actually work? What does the training data look like? How do you install this skill?
Right, so because it's supervised fine-tuning, it needs special training data. And for RAFT, each training example isn't just like question and answer.
Oh.
It's structured as a triplet, really. A query, a set of documents, and then an answer that's specifically derived from those documents.
Query, documents, answer. Okay, that sounds a bit standard at first. Let's use their IBM parental leave example. Query. How much parental leave does IBM offer?
Right.
Simple enough.
Right. Now, to train the model how to answer that using docs, you give it documents. But here's the clever RAFT twist. The document sets you use aren't just the relevant ones. They deliberately include two types of documents.
Ooh, okay. What are they?
First, you have what they call core documents. These are the ones that are actually relevant. They contain the info needed to answer the query.
Right. For the IBM leave question, that'd be the HR policy docs, eligibility stuff, duration, pay details.
Exactly. The stuff you want the retriever to find. But then the second type is tangent documents. Tangent. These are documents that are completely irrelevant, off-topic noise. For the parental leave query, this might be, I don't know, documents about IBM's 401k plan or internal coding guidelines or what's on the cafeteria menu.
Hold on. Why deliberately train it with irrelevant stuff? Isn't that counterproductive? Don't you want clean data?
But see, this is one of the really smart kind of counterintuitive bits of RFT. It's key to making it robust.
Wow.
You include tangent documents precisely because real-world retrieval is messy.
Okay.
Your RA system in the wild, it's never going to pull only perfectly relevant documents. It'll grab a mix, and often a lot of that mix will be noise. RAFT trains the model to deal with that noise. It teaches it how to filter, how to spot what's useful versus what's just junk within a pile of documents it's given.
So it's not just learning to find the answer, it's learning to ignore the distractions. That's a really critical skill.
Hugely critical. And they push this simulation even further. They structure the training examples using these two document types in two specific ways. They create two kinds of document sets for each query during training.
2 sets per query. Okay, tell me about those.
So for a given query, like the IBM one, they create set 1. This set has both the core relevant documents and some of those tangent irrelevant documents mixed in.
Okay, so the leave policy docs plus the 401k docs.
Exactly. This mimics a pretty common retrieval outcome. The retriever found the good stuff, but it also pulled in some unrelated clutter. The answer's in there, but the model has to sift through the noise.
Got it. Set 1, noisy but successful retrieval. What's set 2?
Set 2 for the exact same query contains only tangent documents. 0 core documents.
Whoa. Okay, so just the 401k docs and coding standards. No parental leave info at all.
None whatsoever. And this simulates retrieval failure. The retriever went looking, but found absolutely nothing relevant to the user's actual question.
Okay, that is really interesting. Why is that so important?
This is maybe the game changer for building systems you can actually trust. By training the model on examples where the context it's given does not contain the answer, you teach it what to do then.
Right. Does it just try and make something up based on the irrelevant stuff?
Or does it learn critically when to say, I can't find the answer in these documents?
That is huge. Teaching an AI to recognize the limits of the context it has and to know when it doesn't know based on that context, that's fundamental for fighting hallucinations, right?
Absolutely. It directly attacks that tendency of LLMs to just confidently make stuff up when they don't have the facts.
Yeah, that plausible-sounding nonsense drives everyone crazy.
So this builds in a layer of reliability. The model isn't just trying to squeeze an answer out of whatever text is there. It learns to check if the answer can reasonably be found there.
So how does it learn to navigate these sets? Filtering set 1, recognizing the failure in set 2. How does it arrive at the right answer? Or no, it can't. Is this where chain of thought comes in?
Exactly. Chain of thought reasoning plays a big part, specifically in how the training data itself is created.
Okay.
For the training examples that do have core documents, set 1, the correct answer isn't just provided like, here's the answer. The training data also includes the step-by-step reasoning, the chain of thought that shows how to get the answer from those specific core documents while ignoring the tangent ones.
So you're showing the model the working out.
Okay.
Like step 1, scan documents for parental lease policy, found in Doc A. Step 2, look for duration, page 3 says 16 weeks. Step 3, ignore Doc B about retirement plans. Step 4, final answer, 16 weeks.
Basically, yes. You're teaching the model the process. Identify relevant sources, extract key info, discard irrelevant info, synthesize the answer logically. This doesn't just teach it how to use documents for that question, it guides its whole reasoning process for similar tasks later on.
Okay, so this whole setup, the query, the core and tangent docs, set 1, set 2, simulating failure, the chain of thought reasoning, that all creates a really sophisticated training data set.
Right.
And you use that data set for supervised fine-tuning on your base LLM.
Exactly. And the sources really highlight 3 key reasons why this RAFT approach works so well.
The first was including those tangent irrelevant documents.
Yes. Training the model to sift through noise is vital. It prepares it for messy, real-world retrieval. By learning to separate signal from noise during training, it becomes much more accurate and robust when it gets noisy results later on, domain-specific questions. It's less likely to get confused by irrelevant stuff.
Build that filtering muscle. Okay, what's the second key thing?
That goes back to set 2, deliberately training with examples where the documents don't have the answer. This is maybe the biggest leap for trustworthiness.
Right. Training for failure.
It trains the model how to handle retrieval failure gracefully. It learns not to just invent an answer from unrelated text. Instead, it learns to recognize when the context is insufficient and, ideally, say so, to communicate that uncertainty based on the sources provided.
That feels like a massive shift for building systems you can actually depend on, especially in important areas. A model that knows its limits is way more useful than one that just guesses confidently.
Absolutely. It builds trust because you know it won't just make things up if the data isn't there in the context. It changes the goal from always answer to answer accurately if supported by context.
Okay. And the third key aspect driving RAFT's effectiveness.
That's the role of the chain of thought reasoning during training. By teaching the model the process of getting the answer from the documents, not just the final answer, you give it a more transferable skill.
Right.
It helps stop it just memorizing question-answer pairs and instead encourages a more general ability to reason using documents. Plus, and this is huge for businesses, it naturally boosts transparency and traceability.
Transparency. How does training with chain of thought help with that later, when the model is actually being used?
Well, because it's been trained to follow these step-by-step paths, it's more likely to generate its own reasoning when it answers a question during inference. It can often point to which documents, maybe even which sentences, it used.
So you can check its work.
Exactly. You can audit the response, you can follow the breadcrumbs back to the source material it was given, and see if its conclusion actually holds up.
That's massive for debugging, for validation, for just building confidence in the output, especially with, medical or legal stuff. You get the answer and the references.
Precisely. So you combine training with noisy data, explicitly training for retrieval failure, and guiding the reasoning with chain of thought. And what you get is a model that's way more robust, accurate, and trustworthy for these domain-specific tasks compared to just RAG or just fine-tuning on their own. And it scales pretty well, too, because you can update the document database underneath like standard RAG, and the model, having learned how to use documents, can often leverage that new information without needing a full, costly retrain every single time.
Okay, so wrapping this up, RAFT is really about teaching LLMs this complex, fundamental skill: how to intelligently use external information. Blending its existing knowledge with the ability to look things up, filter out the junk, and crucially, know when the answer just isn't there in the provided context.
It's a significant evolution, definitely. It tackles the main weaknesses of ARG, like relying on a perfect retriever or handling noise, and the weaknesses of fine-tuning, like not handling new info or hallucinating outside its training. It builds a model trained to be a competent user of external docs.
And the results are better accuracy, fewer hallucinations because it can say, I don't know.
Yep. Increased transparency because you can see its reasoning, and just better robustness overall.
It really does feel like a big step towards making LLMs reliable partners for specialized tasks.
It offers a really strong blueprint for developing AI that can reason over specific, changing knowledge bases with, well, a much higher degree of confidence.
So here's something to maybe chew on, building on all this. Think about the implications of an AI system that's specifically trained not just to find info, but to understand the limits of the info it finds. How does that ability for an AI to look at the context it's given, know when it doesn't know the answer from that context, and then either use its internal knowledge or just state its uncertainty? How does that fundamentally change how we trust and use these systems in really critical situations?
Yeah, think about that shift from a model always trying to give an answer to one focused on the correct, verifiable answer from the context, or saying when it can't. How could this teaching the model to fish properly change things in your own field or areas you're interested in?
It definitely makes you think differently about reliable AI and where that trust comes from.
Absolutely does.
We would genuinely love to hear your thoughts on this. What stands out to you about RAFT? Or how do you see this ability for an AI to know its contextual limits changing the game? Let us know your opinions, your suggestions down in the comments.
Yeah, definitely. And if you found this deep dive useful or interesting, please do give us a like. It really helps.
And of course, to catch all our future deep dives on topics like this one, make sure you hit that subscribe button.
And ring the notification bell, too, so you don't miss out when new ones drop.
And finally, if you know someone else who might find this RAFT approach as interesting as you did, please share this deep dive with them.
Thanks so much for joining us today.
We'll see you on the next one.